Hi, my name is Kate Balicki, and today I will be solving problem 17.5 in the topic of acids and bases. The problem is as follows. A 0.148 molar of a monoprotic acid has a percent ionization of 1.55%. What is the acid dissociation constant for this acid? In this problem, we are given the initial concentration of the acid, 0.148 molar, and we're also informed that this is a monoprotic acid, which means that the acid can only give up 1 proton per molecule. We're also given the percent ionization, 1.55%. It's important to remember how to find percent ionization. In order to do this, you take the concentration of the ionized acid, H3O+, and divide it by the initial concentration of the acid. Multiplying by 100 will give you a percentage. It's important to note that strong acids have higher percent ionizations, so we know that this will be a weak acid that we are dealing with. We're asked to find in this problem the acid dissociation constant, which is also known as Ka. In order to solve this problem, I'm going to start by using the given information and the percent ionization formula in order to solve for the concentration of H3O+. Next, I will use a Rice table to organize my values of the initial and final acid concentrations using both the values I was given and the values that I found. Finally, I will work in reverse and solve for Ka by plugging in values from the Rice table. First, I'm going to solve for the concentration of the ionized acid using the percent ionization expression. I'm given the initial concentration of my acid, 0.148 molar, and I'm also given the percent ionization, 1.55%, which in decimal form is represented by 0.0155. By cross-multiplying, I can solve for the concentration of H3O+, which comes out to be 2.29 times 10 to the negative 3 molar. Next, I'm going to create a Rice table using the initial and final concentrations of the acid. I've provided a hypothetical expression in order to allow you to visualize where exactly these values are coming from in my Rice table. First, I'm given the initial concentration of my acid, 0.148 molar. I also solved for the concentration of H3O+ in the prior step of this problem, so I know that that will be equal to 2.29 times 10 to the negative 3 molar. Next, since we found the concentration of H3O+ in the previous stuff, we can say that the concentration of H3O+ is actually equal to X, and this will allow for us to solve for all the other values in our table. Finally, I will use the data from the Rice table in order to solve for Ka. Ka in this situation is represented by the concentration of the products divided by the concentration of the reactants, excluding all liquids and solids, so water is not a part of this. So I will take the concentration of A minus, which I know is equal to X, which is 2.29 times 10 to the negative 3 molar, and I'll multiply that by the concentration of H3O+, which I know is also 2.29 times 10 to the negative 3 molar. By dividing this by 0.148 molar, I will be able to find the final Ka value, which calculates out to be 3.61 times 10 to the negative 5. In conclusion, we were asked to solve for the dissociation constant, Ka, when given percent ionization in the initial concentration of the acid. To find the final concentration of the acid, we used the percent ionization formula. A Rice table allowed for a view of all values in order to finally solve for our Ka, which was equal to, again, 3.61 times 10 to the negative 5.